Hey everyone, welcome back to Math with Vanch. I'm Vanch and I'll be teaching math, obviously. So in the last video we looked at what the power rule is, and it's basically just a way easier way of finding the derivative. My bad. Okay. In this video we'll basically kind of be working backwards a bit and be looking at some properties of the derivative, or how to evaluate them in function form. As I think you'll see, it's pretty easy and straightforward, so this shouldn't be too long of a video. Now if you're ready, I am too. Let's get started. Okay, so there are 4 basic rules that we will be looking at in this video, and they're all pretty straightforward and I feel like pretty intuitive too. You probably could have guessed them before, but it's good to just know that they exist. So here are some of the derivative rules. Now, if you remember from the last video, I showed you guys some ways to notate the derivative or derivative notation. So suppose we wanted to take the derivative of f of x, right? So the way we would denote that is we could do it 2 ways. We could either do this d over dx thing with f of x in brackets, or the other way we could do it is we could do f apostrophe x. The way we say this is f prime of x. So for the sake of this video, we will be using this form of notation just because it makes it a bit easier to teach. But on AP exams or tests or something like that, you will be seeing both of these most likely. Okay, so now that that's done, let's look at some properties. So the first property is called the constant property. So basically it says if we have the derivative of a constant, so constant we'll say k, and k is just any number. It can be any number like 1, 2, 3, could be fractions, could be decimals like 0.5, 1/2, anything, okay? Just any number as long as it doesn't have a variable. So the derivative of a constant is just going to be 0. And the way we can prove this is basically think of k as a function, right? Suppose k was a function, so we would have y equals k. Now if we were to graph that, we would just have a straight line like that. And this right here would be k. And if we remember what the derivative is just slope, right? So what would the slope of just a horizontal line be? Well, it would be 0. So for that reason, the derivative of k, or any constant basically, any number in general, would just be 0. Now let's look at another property. And this is going to be the derivative of some constant, we'll use k again, times a function. So this is our constant right here. And this right here is going to be our function of x. Okay. So what would this be? Well, this would just be k times the derivative of our function. So basically what we did, we effectively took this k outside of the derivative, and basically nothing happened to it, right? So we just made it, so basically what this is saying is that the derivative of any constant k times a function is just going to be the constant times the derivative of the function. Also pretty straightforward, pretty easy to evaluate. The next property that we will look at is the sum property. So the sum property basically says that if we had 2 functions, f of x and g of x, right? So, and we wanted to take the derivative of them. Suppose we had 2 functions, f of x plus g of x. Again, really straightforward. It's just going to be the derivative of the first function plus the derivative of the second function. Or the derivative of the second function plus the derivative of the first function, however you want to do it. So this is just going to be derivative of f of x plus the derivative of g of x. Right there. Ooh, I slanted. Pretend that's straight. Just pretend it's straight. It's not slanted. Okay, but as you can see, pretty straightforward. Plus function plus a function, derivative, just derivative of that function plus the derivative of that function. Pretty easy, right? I'm guessing a lot of you could probably have guessed this because it's nothing special. It's just basically distributing this derivative operator to each thing. It's like the distributive property. And finally, we have one last property. And what we can do, instead of plus, we can just do minus. And can you guess what this is? Same thing. Derivative of the first function minus, this time because it's a minus sign, the derivative of the second function. I did it straight this time, see, it's not slanted. But yeah, that's it. That's the 4 properties of the derivative. They're all super easy, super intuitive, pretty easy to remember because it's just the same thing. Again, you just distribute it right here for the constants. It's just 0. Constant multiplied by a function, just the constant times the derivative of that function. Again, pretty straightforward. So yeah, that's it. So that was a pretty short video. We covered all the properties of the derivative. They're all pretty straightforward, pretty easy to remember. I don't think you guys should have too much trouble with those. But I hope that you enjoyed this video, and I will be seeing you for the next one. Bye bye.